Determine the limit as x approaches 0 of x squared times the cosine of 1 over x. So the limit as x approaches 0 of x squared times the cosine of 1 over x. The first thing to do is try plugging a 0 in for each of the x's. That will give 0 squared times the cosine of each term that is a constant divided by x to a positive power will go to positive or negative infinity as x approaches 0. 0 squared is 0. The cosine of positive or negative infinity is indeterminate, but it will remain finite somewhere between negative 1 and positive 1. And since it's multiplied by a 0, this limit should exist and can be found using the squeeze theorem. The cosine, no matter how weird the phase is, it's a 1 over x here, will be bounded at most by a negative 1 and a positive 1. We can now multiply all of these by x squared so that the middle function will look like the limit we were trying to find. Negative 1 times x squared is negative x squared. X squared times cosine of 1 over x, positive 1 times x squared, and this inequality set holds true. We have formulated the function. Now what's left is to take the limit as x approaches 0. This will be done for each of them, and it still holds true. The leftmost limit, the first thing to do is plug a 0 in for each of the x's, which will give a negative 0 squared. The middle limit we will leave alone, since it cannot be determined as is. The rightmost limit, we can plug a 0 in for each of the x's, which will give a positive 0 squared. 0 squared is 0, and the negative of 0 is still 0. And 0 squared is 0. The middle limit is being squeezed between 0 and 0, and therefore, from the squeeze theorem, the middle limit has to equal 0. And we have determined the limit as x approaches 0 of x squared cosine of 1 over x, and it equals to 0.